Good morning, I'm Manuel Zarzo, and in this Unit 5 Inference, I will talk about the student t-distribution, which is an important distribution that is used in sampling. Okay, so this distribution has a special name, or maybe a strange name. Why is it called student? Is it because it was developed by a student of statistics? Well, not actually. The story is a bit curious, and I would like to explain about that. It was first derived in the year 1876 by Helmut Durer, but this distribution takes its name from Gosset. In Gosset's scientific paper that was published in the journal Biometrica in the year 1908. So this author, Gosset, published that paper using the pseudonym student. Okay, so he did not use his real name, but he used a pseudonym. So, and then the reason, well, this is a picture of Gosset. Well, the reason is that Gosset worked at the Guinness brewery in Dublin, and he was interested in problems of small samples. So why did he use the pseudonym in this paper? It seems that Gosset's employer, which means Guinness beer, did not want their competitors to know that they were using the t-test to determine the quality of raw materials. Okay, so a way to prevent this is that he used a name that was not his real name, and in any part of the paper appeared the Guinness industry. Okay, well, this is like a curiosity to explain this strange name of student. So it was not a student of statistics who derived that distribution. Well, this is the shape of the student t-distribution. It's symmetric with an average always 0. Okay, and it also depends on degrees of freedom, like in the chi-squared distribution that I explained in the previous videos. Okay, so when the degrees of freedom is just 1, we have this one, and when the degrees of freedom is infinite, it is exactly the standard normal distribution. Okay, so we can see that when the degrees of freedom are small, like 1, 2, or 5, there is some kind of deviation with respect to the standard normal, but when the degrees of freedom are big, quite fast, it tends to the standard normal. Okay, well, then this is the theoretical definition. A student t-distribution is that when we have, imagine like 2 columns of values. We have one column of values from a standard normal distribution, then we have another column of value with a chi-square distribution with n degrees of freedom, and then we compute a third column by applying this formula. Okay, so if we then make a histogram with these values, that values will follow a student t-distribution with 1 degree of freedom, with the condition that they are independent. Okay. Well, the average is 0, which makes a lot of sense because the average of the standard normal is 0, and because as the average of the chi-square is n divided by n is 1, the square root of 1, so on average we are dividing by values which are 1. Okay. The variance is this one, so when n is big, so this is approximately 1, so but when n is small, so the variance is not exactly 1. So this is exactly the exact calculation for the variance. So the most important rule is that when the degrees of freedom are big, tend to infinite, so the student t-distribution tends to the standard normal. Okay, but anyway, just for about n30 or 40 or 50 more or less, the approximation is good. Well, this is the shape for 5 degrees of freedom. This is the density function with 50 degrees of freedom, and then you can see that there's just a slight deviation. So 50 can be more or less considered like the standard normal, and then the t is just very similar to the standard normal. So this is why it's quite easy to remember what the student t is. And this is the table. That we have to make the probability calculations. Well, sorry that here the table has been mixed. And then this is the shape of the student t-distribution, and this is called the critical value. Okay, the same was in the chi-squared distribution. This is called critical value. So if the error on the right side is called alpha, okay, the value, so that on the right side the value, the probability is alpha, this is called critical value. So that values of alpha are the ones that appear here in the first row, okay, that are the values alpha. Okay, and here it's interesting that we have 120 degrees of freedom, and then it goes to infinite, and then it seems like a bit strange. So we have 120, and then it changes to infinite. What does it mean? Well, infinite implies the standard normal distribution, and then if we compare the values, we can check that 120 more or less the values are similar. It means that the approximation is good. Okay, and then for example, this value is 0.05. This is the most common value of alpha used in statistics, 0.05 and also 0.01. So for intermediate values, we can use linear interpolation, which is a process that I explained in the previous video. Okay, so for example, this could be an exercise. Obtain a value x so that the probability that this distribution in absolute value is bigger than that is 0.05. Well, as it is in absolute value, so we should not read on the column 0.05 but on the column 0.025, okay, because we are working in absolute. So then we will go to the row 10 and then we will read the value. Well, sorry that here you cannot see this very well. So this was my mistake. The solution is 2.228. Okay, importance of this distribution. So if we have that the sample average and the sample standard deviation are the mean and the standard deviation of one sample of size n taken from a normal population, okay, remember, important, in this unit, in inference, we will always assume that we are dealing with a normal population. Okay, so if we compute this statistic, okay, so the sample average minus the population average divided by the sample standard deviation divided by the square root of the sample size, okay, this statistical parameter follows a student t-distribution with n-1 degrees of freedom. Okay. Then it's important to compare the analogy between this and this. Okay, so if I divide by sigma, the standard deviation of the population, or if I divide by s, the standard deviation of the sample, both will be similar. Okay, well, in the first case, I will have the standard normal distribution. This is a formula that I explained in some videos before, but here the formula is the student t-distribution. Okay, so what happens if the number of degrees of freedom is high? Well, if the number is high, then S tends to sigma, which makes a lot of sense. If the sample size is very big, it's nearly like the size of the population, the standard deviation of that sample will tend to the standard deviation of the population. And then in that case also, as I have explained, the student t-distribution tends to the standard normal. So this formula tends to that formula when n is big. And then here I finish this video about the student t-distribution.